YakChat, a podcast from BlakYaks. In this episode, Craig Hurt, Cloud and DevOps Lead, joins BlakYaks CEO Dirk Anderson to delve into why Azure Automation is central to modern business transformation and a critical driver for digital success.
Good morning, welcome. I'm Dirk Anderson. I head up the team here at BlakYaks, and today we're joined by Craig Hurt. Welcome, Craig. Thanks for joining. Can you introduce yourself and tell us a little bit more about yourself, your career, and the role that you do at BlakYaks?
Yeah, cool stuff. Yeah, morning, everyone, wherever it is you're listening to this. I'm Craig Hurt. I'm the BlakYaks Cloud and DevOps Lead. So my role within the business, as you know, Dirk, is to manage engineering and automation within the business, building patterns and standards, really working around the DevOps and the CI space for our customers.
Yeah, and how did you arrive at BlakYaks, Craig? What's your history before that?
So checkered history, many years in the industry, 25, 30 years now. Started out with infrastructure support. Mm-hmm. I've worked as a developer in the past, and then I've worked through architecture, system architecture and design, and then I've come back into a sort of hands-on technical role here. Yeah. So I like to keep my hands dirty.
You're back where you belong. We're glad to have you, Craig.
Yeah, proper techie.
So just to introduce this episode, this is the fourth in the series. Previous three episodes we covered modern cloud operations. We then talked about application modernization. We covered enterprise container platforms in Microsoft Azure. And I guess there was a bit of a running theme through all of those, which was the need for really good automation, DevOps, infrastructure as code. And this episode today is all about that, really. It's about diving a little bit deeper around Azure Automation and what excellent automation looks like. So before we get into that, Craig, I guess it's hard to talk about automation excellence without talking about DevOps and DevSecOps and GitOps and platform engineering and how that's evolved over the last couple of decades. It'd be great to get your take on, that landscape.
Yeah, it's been quite a big change really in the last 10 years or so. So I guess when DevOps was born, I think we've probably all people in this industry all read the Phoenix Project, and it was this big picture of how things should be done and how developers and the automation people and the infrastructure guys all work together as a single team. Yeah. And it kind of started out that way. It was fairly successful in some industries. So what happened was the devs really wanted to get quicker to production, but to do that they needed the infrastructure to be spun up, and there was always this developers versus infrastructure or ops barrier. So what DevOps was supposed to do was to bring those two together so the developers they could spin their own infrastructure up and reduce that delay. And it happened for a while, and you found some organizations were better at it than others, mainly the ones who were very dev focused or born in the cloud technical people. Yeah. What actually happened though is what the devs didn't really want to be doing that piece of work in the end. And so what's happening now is you're kind of getting this division back into operations and developers. So the developers are managing their code and they're building their applications, and the infrastructure guys are still building their infrastructure, but they're doing it in a sort of platform engineering guys. Yeah. So they're trying to produce an interface for the devs to consume infrastructure easily, but still with guardrails so that they don't deploy it wrong, and everyone who needs to be involved in it is still involved in it. So security and all of the financial management is taken care of.
Yeah, I guess if I go back some 20 years or so when I was running a virtual DevOps function then, it was much more about getting developers and infrastructure and operations team to collaborate better together, because infrastructure teams were really holding up their ability to code and release applications quicker. So that I guess there was this drive to want to get the control back in their own hands so as they could speed up their own process. But I guess they didn't quite realize development communities, the responsibility that came with.
Yeah. I mean, obviously a developer wants their application running as soon as possible, right? They don't really care where it runs or how it runs, whereas the infrastructure guys, they're supporting this system when it goes live. So they need to know it's being monitored properly. Yeah. The security people need to know it's secure, so they need to make sure it's patched and monitored and everyone's aware of what's going on with it. But the devs don't care about that. So yeah, the developers never really were that good at it. Yeah, I think is the long and short of it, whereas the infrastructure guys are good at it, but they don't understand the development side. So there was always that division. I think it never really sat that well.
Yeah, so it's kind of gone full circle, right? Developers, we want to control our own destiny here. Comes with a lot of responsibility, especially very large organizations where security and platform engineering and resilience really matters. But it sounds like we've gone full circle now. And platform engineering, or good platform engineering, is now back in the hands of the infrastructure teams and the operators, and arguably where it should be.
Yeah, no, agreed.
And what's changed that, Craig? 'Cause I guess, when I think about how pervasive cloud is becoming, cloud native, I guess it's allowed for some of that, right?
Yes, I think with cloud native implementations, it's more dynamic. There's a lot more infrastructure and it's a lot more immediately available.
Yeah.
So previously, if you think back to, you had an on-premise environment, infrastructure would need to go for a firewall change. They would need to spin up some tin somewhere.
Yeah.
So maybe rack some hardware and then provision servers within it. It took time.
Yeah.
With cloud native, it's a click of a button really, and it's available. Yeah. So all of these APIs, and it's an API driven architecture now, it lends itself to tooling that supports those APIs and allows things to be done quickly and consistently. And that's what never really existed in days before DevOps. So you always did it with scripts, or you had a process that was manual with like service tickets and things like that. That's all gone now. So we have to have an agile process to manage the agile infrastructure behind it.
I suppose there's no argument really that cloud and cloud native platforms and services really lend themselves to higher quality automation. We could do some of that in the hypervisor space, but not quite at the same level.
No, I think the hypervisors, they didn't really have this API interface, and there was always that sort of manual process behind it, and you needed to sort of tune it to your requirements a bit more. With IAC and with cloud environments, it's very much more of a declarative model where if it works in one environment, it's going to work in another because it's built on the same cloud platform, same fabric. So yeah, that's where we are these days. It's having that standard interface into the infrastructure that allows us to do this quickly and consistently. Yeah.
So over that period, gone from original DevOps to platform engineers become more of a thing. I know if you look at collateral we put out there, look at our website, we talk about DevOps and DevSecOps and GitOps because that's where the market's kind of at, and you need to. But I guess we see ourselves a bit more as a platform engineering function. It'd be just good to get your view on that, Craig. What does good look like when you think about platform engineering and its definition in the stuff that we do from a cloud standpoint?
I think platform engineering and what good looks like in IAC and in DevOps is it shouldn't get in the way. And platform engineering was born as a quick vehicle for developers to get their infrastructure quickly through a single interface where they didn't have to worry about all the stuff that's behind it. So they didn't care how it happened. They say, I want my infrastructure, I'm going to go through this portal, I'm going to select that, and it's just built for them. But with platform engineering, all of the stakeholders that care about the infrastructure have their input. So security teams know that everything's in policy. Yeah. The cost people know how much it's costing and can deny access if it's too expensive. And the infrastructure guys know it's built to a standard and it's all monitored when it goes in. So all of that stuff's pattern based with platform engineering, and you don't have to keep rolling this same process each time. It's done. The developers know it's done. The infrastructure guys know it's done. So it's consistent. It kind of keeps all the stakeholders happy. Yeah,
and I suppose the tooling's helped with all of that. I mean, if we talk about infrastructure as code and the tooling and the progression of that tooling over the last 10 years or so, give us your take on that. Okay, I guess that plus APIs. So there's been an improvement in both of those areas, which I guess is a bit of an enabler for some of this stuff.
Yeah, and I think we talk about declarative versus imperative tooling. So imperative being you're going to write these scripts yourself and you're going to implement them and you're going to run them at a console somewhere. Where actually what we do is everything's pipeline driven or scheduled. So declarative code allows us to say, I want it to do this, but I don't care how it does it. So all of that automation complexity is taken away. And the tools like Terraform and Bicep are interfaces into this declarative way of working. And that's only possible through APIs.
Yeah.
But with the cloud environments, they change so quickly. You don't want to be completely hand cranking these scripts all the time like we used to. Because on premise, you would have control over the infrastructure you were going to run against, right? But
it's more static and more static in nature. Yeah,
cloud's constantly moving, so you need software that can move at that pace with it. And also, there's the scale of what we do these days as well. So it's not 5 servers now; it's 500. It might be pods in a cluster, and it's got to be that quick.
Yeah, and I suppose that's an important piece of context for us. Is we typically, as a business, we serve larger customers, large to enterprise style customers who've always got this kind of scale challenge. So they need to do what you've just talked about well. You've just got to get that stuff right, haven't you?
Yeah. And I think we often talk about foundational engineering and how that's underpins everything. So we talk about platform engineering. Actually, platform engineering is a facade that interfaces with your IAC and your foundational stuff. So if you don't build your code right, and you build it to bad standards, or you're not doing things in a consistent way, that will come back and bite you later. So you need to make sure that those basics, because they follow through the whole of IAC.
Yeah.
It's getting that foundational layer correct, which is the most important thing.
Yeah, I suppose in these episodes we're in danger of repeating ourselves a little bit, but it's really what we're all about, isn't it? It's making sure that the automation quality is really high. So whether we're dealing with a customer's enterprise container platform design, build, deployment, or Azure landing zones, or something else, data platforms, the thing that underpins all of that is really good platform engineering foundations and high quality IAC, which is why it seems and feels a bit repetitive. If anybody bothered to listen to all these podcasts, all these episodes, that's kind of at the core at it.
Yeah, I mean, we get bored of saying it, don't we? But actually, the thing with IAC is, and this is where some businesses have trouble with it, is it's not based on old infrastructure. So it's not the way we used to work. It's more working in the way of a developer. So your code standards have to be right. Your Git hygiene has to be correct. You have to have standards for developing. You want to make sure it's consistent. All of that sort of rigor that comes into IAC code development never existed in the old days. Yeah. And if you've got to have that mindset to do it properly, you've got to treat your infrastructure as code. Just clues in the name, right?
That's probably right. And you kind of whiz through it. I mean, as an Azure kind of cloud native specialist partner, you touched on Terraform and Bicep. Just talk a little bit more about that, Craig, if you would. Just why not Bicep as a Microsoft partner? Why is Terraform more of a fit for what we do and who we serve?
So Bicep is a fairly recent development. So anyone who's worked in Azure for some time will know the horrors of ARM templates and what we used to have, and that was all we used to have. We're big advocates of Terraform for a number of reasons. One is its longevity. It's been around a while. It's got great vendor support, but also it's not Azure specific. So Bicep at the moment supports only Azure, but actually if you're working in an Azure environment, it's very rare that you're just working in an Azure environment. So you've got all these peripheral services around the edge, like, I don't know, Palo Alto firewalls or Azure DevOps or something like that. And all
heaven forbid, other cloud providers in large organizations.
Even GCP or AWS, if we are allowed to say that. But so you need this tooling that's consistent across. And Terraform gives us that standard interface. So we can develop code against any of those platforms. And actually our skill sets and our standards around our IAC modules carries across any of those. So with Bicep, we would have a different set of standards because it's a different language ultimately.
And when we're engineering these platforms, it's often that we'll be using, tools from the CNCF landscape. Could be open source, could be third party, or indeed just third party off the shelf tools. And we want to be able to automate those as a way to enhance what you get natively in Microsoft Azure, and Terraform helps with some of that.
It does. And then the other thing with Terraform is the state management. So you've got drift control. So if someone's changing things manually, Terraform will correct that. That doesn't exist in Bicep today. So that's always been a big seller of Terraform for us.
And good IAC, Craig, great IAC. What does that look like? Have you been giving some guidance to people that are maybe this is relatively new to? What does really good IAC look like?
I would always say start simple. Yeah. So IAC, we would always class ourselves as creating elegant solutions. And what we mean by that is we don't over-engineer what we're doing. You need to keep things simple and maintainable and also modular, right? So IAC, the benefits of IAC come from programming tenets of like, don't repeat yourself and develop once, and modular code.
Yeah.
All of that's important with IAC as well. So great IAC is done well because you're modularizing your code, you're getting code reuse, parameterizing everything so it's reusable across different use cases. It's about having a library of code that you build up over time, but good practice. So good Git hygiene, version control, code reviews, all that stuff you do with software, do it with your IAC.
You were talking, Craig, about modular IAC code and what does good look like, and just talk a little bit more about that, if you will.
So our take on modular code is reusable bits of code that we can use across multiple use cases. Yeah. So with IAC, you've got inputs and outputs into your modules. So your inputs are variables or parameters that you pass in. Outputs are whatever that module did. Yeah. You want to make as many parameters into your code as you can, because that gives you as many use cases for that as you could possibly use, right? We need good standards. You need good code hygiene on IAC. So all modules are written like software. So it's, all of the stuff that we talked about previously around Git hygiene, version control, code linting, checks on security standards, all that stuff needs to be done in a sort of process around your IAC software library.
Yeah, and that's the leap, isn't it? If you getting all of that stuff right is the leap that we would encourage, especially large customers with the budget and large technology estates. It's worth making that leap. And the business benefits, we won't cover here today, but are huge, right? I mean, we've got a recent customer we work with where we've been very compliant with their own standards in terms of deploying, in their case, a large enterprise container platform on Microsoft Azure. But getting that code base right means we could just deploy it. I think they've got an appetite to get it deployed to 8 or 9 different parts of the world, and the ability to do that consistently, big deal.
Yeah, and that's the thing with IAC, it's parameter driven. So you can build your code base once and then put parameters in for each region, for each environment, and just tweak things as you need. But actually that code stays the same. So when you're deploying in dev, it's going to be the same as in QA as it's going to be in prod. You've got that flow, and you can confidently say that my environment in dev is actually, it might be different size, but the code is the same. So when you test it, it's valid across all those environments. You can't do that without IAC.
Yeah, and if you're a SaaS provider, great example, large SaaS provider, your ability to roll out your application on top of these platforms with absolute confidence that you'll get the same experience everywhere else is a big deal for businesses. Not to mention disaster recovery, business continuity, your ability to roll back to good known states and be able to recover to a point in time that you're absolutely confident about. And if you've got a problem with your code, rolling it back. When we talk about all this stuff, I know we love to get into the tech, but it's really all about the business benefits ultimately.
Yeah, and also if it's a library of code that's in version control, you're maintaining one set of code, and it can be a centralized portal of code, right? And so if you've got different business units that have similar requirements, might be slightly different. Yeah. You can have a central code set that's managed, and you're not having that duplicated and amended across the business. You're doing it once, but you're doing it well.
And you've talked about IAC modules, Craig. Just talk a little bit more about how small should they be? I know there's some internal debate around getting that stuff right.
There is. There's some trains of thought that think you should modularize literally everything down to the atomic level. So a resource group in Azure, for example, they would say you need a module for that. Now, my take is slightly more pragmatic than that. I think you want to have your modules as logically grouped infrastructure. So, for example, a web server, if that needs a key vault with it and some other peripherals, you would put that all into one reusable module. Yeah. And ultimately what those modules are and that unit of modularity is down to the business requirements and how you're going to use it. So if I talked about parameters earlier, there's no point in putting parameters into a module you're never going to use, because then that's technical debt you've got to manage. Yeah. Just make it do what it needs to do at that time and expand it when you need to, if you need to, but don't try and cover everything and every angle from the get-go, because you'll never get anywhere.
And it sounds like reusability is the key here, right? If you're not going to reuse the module, why would you bother? That's key. You started to talk about Git, Craig, and I know you and the team do a lot of work around Git Ops, in particular, especially in an enterprise container platform context. But so Git's becoming a bigger focus in how you get that right and how you manage it in an IAC context. You just want to talk a little bit more about Git, and what good looks like in terms of management and controls.
So source control is at the center of everything. It's at the center of everything now, and it's going to become more prevalent with GitOps based flows. Yeah. So you need good hygiene in terms of when I talk about hygiene in Git, I'm talking about knowing who can access that code, who can access which branches are available to the endpoints. All of that sort of security model gets wrapped in, including things like approval gates. So if you do a change, in people who know Git, to put a pull request into a branch to merge that code in, you've got to have the right sets of eyes on that. Yeah. They might not always be human eyes. They could be virtualized these days, or AI coming in.
Yeah, we got onto that at some point.
But you've got to have that process and that governance around it. And GitOps, the real advantage to this Git-based flow is it's a pool-based architecture. So if you've got 2 clusters, then that's quite easy to push that code out to those clusters. When you've got 500, then that's a different story, right? Yeah. So what GitOps does is it allows the endpoints to pull that code. So you actually commit the code into the Git repository, and all of that deployment is done automatically by the endpoints.
So you need to be pretty confident at the point of the commit, because your infrastructure is going to change as a result of that.
Yeah, double-edged sword, because if you deploy that and it's wrong and 500 clusters go, right, there's my changes, I'm going to deploy that, and then you've got a problem, right? And you can roll it back because it's Git, but then there's the pain and does it work? So yeah, you've got to be careful.
I guess that's the interesting flip your platform engineering, infrastructure, cloud infrastructure teams need to make, is the way that they would have thought about existing provision deployed infrastructure and the kind of controls that you need to apply to that, where it's role-based access controls and all of those methods that are, well grounded within our industry. As a platform engineer, a cloud infrastructure function, having to manage Git repositories with that kind of same rigor, that's really what we're saying here, isn't it? It's because that becomes your infrastructure. It's not deployed yet, but what is deployed is entirely affected by...
It is, but it's your single source of truth as well. So it's a nice audit trail. You can see who's changed what, why it was changed, when it happened, who approved it. Not that you'd want a witch hunt, but you've got a way of tracing it back to source if there's an issue. Which you never really had in old days. You would just have file shares holding your code or a bunch of scripts, and someone would run it. You wouldn't know they'd run it. You wouldn't know that code had changed. So you've got all that visibility now. So Git is a good vehicle for this.
Something's happened. What is it? What's changed? And you get away from all of that.
That's it. And also, because it's Git based, and again, it comes back to this multiple environment thing. You could have different branches deployed to different environments. GitOps models will work like that. But you've got that certainty about if it worked there, it's going to work here, or it should do. It should do most of the time.
Yeah, and we might have covered it in the conversation, Craig, but when you look out 2 or 3 years, where do you see all this kind of going? And I know, saying again, in a kind of larger business type context, where do you see it heading?
I think we're going to go more to this pool-based architecture, so we're already seeing it. In terms of IAC, specifically in Terraform, where we've got this, Terraform's always been a push-based approach. There are a few products around the platform engineering space that are trying to go to this pool-based model, so changes are made in code and the PR is approved. Once the PR is merged, the Terraform bits happen. So there's products, Atlantis is one such product that's been around for a few years that's always had that pull-based approach. Terraform Cloud does a similar thing. So I think you'll see more of that kind of facade of platform engineering taking advantage of a GitOps type approach. And obviously in the cloud native world, GitOps is king already, right? So that's where it's going to go. And I think you'll see that technology come on leaps and bounds.
I guess we haven't really touched on AI, CoPilot. As a Microsoft partner, there's obviously a lot of activity and discussion around CoPilot, GitHub CoPilot, for example, OpenAI within Azure. And we're doing a bunch of stuff ourselves in our own labs to make sure we've got the right position in front of customers around this and we know what its value is. What's your take there? Where do you think that might head? What role does GitHub CoPilot, for example, or OpenAI have to play in this kind of world of coding and getting some of this stuff right?
Yeah, so I think Gen AI at the moment is very much focused on the development side. So it's already there, it's in place, and we use it quite heavily, I'd say, internally to develop bits of code. When it comes into IAC, it's still unsure. So there's a lot of helpers around pull request reviews and bots that will check your code and say, I think we should change this, and actually write the code for you and put a pull request in. And that's great. It's all about reducing that churn for a developer, I think, AI at the minute. Where it goes in IAC is, do you trust AI to accurately model your infrastructure and all your business requirements that may be so subtle they're not in code? How can it do that? And so you're always going to need a pair of human eyes on it. But I think AI will become like almost a third-party reviewer to everything we do. So it'll have its input. Whether you choose to listen to it, I don't know. I suppose as the language models develop, they'll get better and better at that.
Yeah, it's a bit of a watching brief right now. I guess what we're saying, go and have a play, do the lab work, really understand where the value is at. But there's a line that you may need to draw right now around at what point do you allow a tool like that, an AI tool like that, to get and approve the release of something to production in a production context. It's coming. It's just a case of making sure that we've got the right controls and
absolutely
around it for sure.
About control. Be a brave early adopter, I think, for some of this stuff. But it's definitely a helper, and I know personally it saves me hours on the coding side. It's not going anywhere.
It's here. But we've got a job for a little while, Craig. That's good. So I think in summary, Craig, we've talked about DevOps, its progression to platform engineering, the critical importance of just getting really good foundations right, getting the ISC right, getting your platform engineering right, using tools like the AI, the OpenAI and the GitHub CoPilot tools that Microsoft are putting out to kind of aid your productivity, but good eyes on it and what good ISC looks like. And thanks for joining us, Craig. You're
welcome. Cheers.
Thanks for taking the time. I know how busy you are. Yeah, thanks for listening in today, those that are still tuned in. This is our 4th episode. We've got another episode to come. We're going to talk about artificial intelligence in a Microsoft context. We'll be joined by a guest from outside of BlakYaks, and if you're interested, please tune in.
And if you'd like to find out about any of the subjects discussed in this podcast, please get in touch with craig.hurt, dirk.anderson or solutions@blakyaks.com, or visit our website at blakyaks.com. You can also find us on LinkedIn, Twitter, YouTube and Instagram @BlakYaks.